Aloha. A little bit louder, please. Aloha. We gave you a lot of sugar this afternoon at lunch, just for a reason, right? So I just like to do some housekeeping announcement, and then we move on with the keynote speaker. First of all, is be noted that this session is on live streaming. So currently, like 5 minutes ago, there was something like 18 people watching the session. And also all the keynotes actually have been recorded. So you can go home and watch on the HICSS TV channel. Just go onto the HICSS website and go to resources. Then all of the keynote speeches that we have had for the last few years actually are up there. And then today's keynote, it will be there in a day or two. And the one from yesterday has already been uploaded. So first announcement. The second announcement is do not, especially for those whose paper got nominated as the best paper for their mini tracks, do not forget to come here tomorrow, Friday at 12:35. Maybe you will be winning the best paper award, and therefore, please don't forget it. Another important event, at least for me, is that we are trying to promote the movement of women in academia. So there is a women networking session this afternoon at 4 p.m. So men are also invited, by the way, to the meeting. So those are the three announcements that I would like to make to you. And then over the last few lunches, people asked me about the meaning of the cover page of this year's conference. Basically, I designed it myself. The color of the island of Maui is pink. This is why you see why the HICSS-52 is in pink. And you see on the right-hand side, the interaction between man and machine. This is why the letter HICSS is hand-drawn. And then the number 52 actually represents part of the chip or the machine that we are dealing with. So this is basically the idea of it. And I would like to remind you that for the last 3 days, if you see me running all over the conferences, it's because of the fact that we are busy working for the next conference. And therefore, I would like to remind you for a call for participation. Those are some of the key deadlines, and we really follow those deadlines very carefully because the conference is getting bigger and bigger. And actually, it is in the conference program that you have. And also, those are the dates and the location and the venues for future conferences. It took us a long, long time in order to negotiate with the hotels. So book your calendar whenever you possibly can. So now, with no further ado, let me introduce you to the introducer of the keynote speaker today, Professor Matthias Jarke from the Technical University of Aachen. Matthias and I, when we were at NYU, we presented, the two of us, the very first paper here at HICSS in 1986, and since then we came back here all the time. So one of the reasons I would like Matthias to introduce the speaker for today is that he just won a huge competition in Germany, getting a $60 million grant on the Internet of Productions. And this is really fitting for introducing a person talking about supply chain management and blockchain. So with no further ado, please welcome Matthias.
Thank you. In the public discussion, blockchain is still closely connected with the rise and fall of Bitcoin. For others, it has become a visionary tool that solves any problems in the world. Which, of course, from time to time leads to a little bit of disappointment and to great opportunities for consulting. And for yet others, it is a threat to public moral because it may be equally difficult to destroy illegal content like pornography or so than other things. We see, I think, a typical Gartner curve with a great start despite initial skepticism, a huge hype, a threatened valley of depth for which we need people who know the way out of that valley or through that valley, And that's what we are seeing in a few moments here. So our keynote speaker, he went through a similar life cycle. A few people came to him and say, well, this technology will transform everything. And of course, he didn't believe it, being an experienced person in IBM research. But after a while, he got himself convinced. Then he started the much more difficult part to convince the top management of IBM that this was really a strategic activity, and he managed to do that as well, but at a price. They moved him from research to development and later to marketing. So from the rather peaceful research environment to the hardships of the real world, but also to great opportunities. So now the next step of convincing was to convince customers, who have to pay for this, which was even great. And in particular in the area of supply chain nowadays, after being responsible for the development of the whole blockchain initiative as a whole. So he must be fantastic in convincing. And nowhere is this more obvious in the fact that he told me that he convinced both of his daughters to become engineers, strengthening what Tung just mentioned. And as being a person who has also two daughters but miserably failed at the same job, I can appreciate what has been done there. He will now show us what has been accomplished in the short span of 3 years after this convincing activity started. If you looked into the program booklet, you have read his abstract, which is a claim, and the convincing is going to happen now. Please welcome Ramesh Gopinath, the Vice President of IBM for Blockchain Solutions.
That was a wonderful introduction. Thank you so much. And thanks for having me here. I'm looking forward to convincing you that blockchain is going to transform every industry. I truly believe that. But my focus will be on trying to at least convince you that in supply chains, things will never be the same again. Okay, so that's my goal. So where's the clicker here? Okay. All right. So in this presentation, what I'm going to do is sort of have 3 sections, so you get a sense of going through those sections. First, I'll give you my perspectives on what we mean by blockchain. It is nothing to do with cryptocurrencies and stuff like that, and so hopefully get on the same page with respect to what we mean by blockchain. Then I'll specifically talk about what we are doing in the supply chain by using one example solution, one of the 2 solutions that I'm responsible for at IBM, and that's IBM Food Trust, where we are trying to transform the food ecosystem to make food safer, etc. So I'll go through that in detail to give you a very good sense of what we mean by blockchain will transform at least the supply chain. And hopefully that'll also give you a very good sense of why I believe that it'll transform other industries. And then finally, in the 3rd section, I'll end with a little bit more on the technical details of how that solution works. So you get a sense of some of the challenges. Since this is largely an academic conference, I wanted to make sure at least I cover a couple of challenges that I share with you for you to think about, okay? So blockchain for me, is essentially a decentralized database with the ability to run some business logic on top called smart contracts. So think of a decentralized database, no single entity in charge of the whole integrity of managing the database. I keep it at that level because then it's a lot easy to understand much of what's going to come. So if you look at the traditional model on the left, right, think of companies interacting with each other, right? They usually send messages back and forth, purchase orders, advance shipment notices, etc. in a typical supply chain. Right? Information silos, disputes, reconciliations are typical. Take a simple example of a buyer, a seller, and a carrier. So Walmart orders computers from HP, and FedEx is delivering it to Walmart. All those point-to-point communication typically end up with Walmart saying, hey, look, FedEx, you know, there was a short shipment or damaged goods. These sorts of disputes and all that can be eliminated largely or transformed in a model on the right, where instead of these companies sending messages back and forth, point-to-point communication, move to a model where all parties send those messages to a decentralized, very important, no one party controls it, decentralized shared ledger or shared database, where when Walmart issues the purchase order, it gets it in there. When HP commissions FedEx, that commissioning to transport gets into the system. So effectively what happens is you eliminate disputes related to various things like short shipment because all three parties have a single version of the truth. That's basically blockchain for us. It's a shared database, decentralized, that allows us to do things like this. At that level, it should be clear that every industry this could potentially transform, right? Because in all industries, companies interact with each other by sending messages back and forth and have their own individual silos of information, and that's what this tries to solve. The other additional point I want to mention is this notion of smart contracts, where the business logic corresponding to disputes, right? So you should deliver goods within a certain time period, right? Did it get delivered or not? That business logic can also be automated, running on the trusted data in this database, and that's basically what is called smart contracts in this community. So that's basically blockchain for us. Now, I wanted to then move to step back a little bit and see, look, there are plenty of blockchains out there, right? So I wanted to give a sense of how to think about the landscape of blockchains, if you will, or distributed ledgers, as some people try to call it, right? So there are at least 20 to 30 different technologies out there. But there is one key dimension you can use to sort of split them into two groups. And it's based on a very simple idea. If you look at a decentralized database, the first question you should ask is, okay, who are the parties or entities or companies that are responsible for managing the integrity of that database? If those parties are known, meaning the identity is known, so a bunch of businesses, HP, Walmart, FedEx, for example, in that case, basically, we call it a permissioned blockchain, right? And much of the work that we are doing in IBM and much of the work that basically you will hear in the rest of the talk will be in this domain of permissioned blockchains. But to contrast that, 10 years ago, we had Bitcoin, then we had Ethereum and all that. The key difference between that world and the world that I just talked about, permissioned, is the fact that the integrity of, say, the Bitcoin blockchain or Ethereum blockchain is managed by anonymous participants, right? So effectively, the burden of making sure the next transaction gets committed onto that database is a little harder problem, if you will, than the permission world. So permissionless world is a little harder technically to solve than permission, but most businesses are not going to be running their business on a database managed by unknown parties, right? So in that sense, much of the action in the business world is in the world of permissions blockchain. So 3 years ago, like Matthias mentioned earlier, right? As some of the folks in my group came and told me that this is going to transform everything, one of the first things that we wanted to look at is, okay, once I got convinced, it was about what technology do we start with to build a permissioned blockchain, meaning one where the companies or the entities running the database are known parties. We looked at multiple options, Ethereum, Bitcoin, to start from that technology to see if we can build something. And very quickly we realized, for various reasons ranging from security and confidentiality, businesses when they run on a platform, let's say if multiple companies are in the system, competitors inclusive, you want to be able to hide information from each other as needed, right? Selective visibility is important in business. Then security, then scalability. The Ethereum, Bitcoin blockchains don't support enough transactions. Visa does 90 billion transactions, 90 to 100 billion transactions a year. If you want to do that kind of transaction volume, you got to come up with something else. So we started and built something from scratch in IBM. So this is 2014 timeframe, 14-15 timeframe. And because we believe that it's going to transform every industry, we decided to donate it or contribute it to the Linux Foundation's Hyperledger project. In fact, we catalyzed the creation of that project. And today we are significant contributor, but many others are contributing to the Hyperledger Fabric and other Hyperledger projects. There are about 200 plus companies in the Hyperledger open source group. So that's one technology that we are behind and we are pushing, but there are several others too. So main point here again, like I said, is much of what I'm going to talk about is going to be with respect to the Hyperledger Fabric technologies, just so you know that for others as needed, we package the Hyperledger Fabric into what is called the IBM blockchain platform. So that's one investment. I will not be talking any more about this for the rest of the talk. The second investment is, we said we're going to build solutions that leverage this technology and learn from what it takes to build a solution and will it truly transform industries. That will be the focus of my talk here on the supply chain space. And then finally, we have also been building solutions for others using the same capability. So for example, build a solution for trade finance for a consortium of banks, a solution called We.Trade. Those are all examples where I would call it's what I would call the services investment. So we invest in platform, solutions, and services. And the rest of the talk, I'll talk about one particular solution in more detail, okay? And overall, just to give you a sense of, over the last 3 to 4 years, what have we been doing? We basically have done about 600 plus projects in this space, right? So it's not a small number. A significant number of projects we have done with blockchain across all industries. As you can see from this picture, multiple industries are represented. But if you look at the very bottom of this chart, right, one of the key things that you'll notice is you see a significant representation from projects in the supply chain. So we stumbled upon supply chain as a good use case, and I'll explain to you why in a second. Excuse me. But yeah, so essentially if you think about supply chains, right, and the mental model you should have is just of, you go and buy, I don't know, mangoes at a Walmart store, right? Where does it come from? That entire set of multiple actors who touch the product as it comes from a farm all the way to you. That's what I mean by supply chain for those who are not familiar with supply chains, right? The key thing you notice is there are multiple handoffs. And so because of the multiple handoffs, it's a good place to think about a shared decentralized database to share information, right? Nobody typically in a supply chain has a good sense of where things are with respect to the state of the goods in transit. So that seems like a reasonable problem to solve. In fact, there are 3 flows in supply chains, the way I see it. The flow of goods all the way from primary farm, let's say, or supplier, all the way to the end consumer in one direction, goods flow. Then there is a flow of money in the opposite direction, money and financing, right? Payments going back all the way to the original source. And finally, there is a flow of information back and forth in the supply chain. I issue a purchase order from Walmart. I get a advance shipment notice from HP, for example, just to use the example I used earlier, right? All of these 3 are rife with inefficiencies is what we kind of quickly realized when we started on this project 2.5, 3 years ago. And so we started looking at specific examples to go spend time on and try to discover how this technology can be sort of used. So that's the journey I want to take you through with 2 examples. I'll spend most of the time on the first example on IBM Food Trust. So what is that? I'll start this by forgetting about blockchain for a moment. Let's think about the food ecosystem. What are some of the problems in the food ecosystem? Everybody in the US at least, is pretty much aware of what happened over Thanksgiving, right? You were all told, don't eat romaine lettuce, throw it all out, right? So food safety is a key, problem in the food ecosystem. But when there is a problem, what do you need to do? If you find a contaminated product, you want to know exactly which farm that product came from, which lot or batch or date that was harvested. So you want to do a backward trace through the supply chain, all the various handoffs. And then you want to do a trace forward because that farm might have supplied not just to Walmart, but also to Kroger and many others. So you want to know all tainted inventory and take it off with a surgical recall. What does it take to do that? It's very clear from what I just described. It requires information sharing across the entire ecosystem, and not just between people in companies in one supply chain, but cutting across competitors too. Because if there's a problem with spinach or romaine lettuce that was sold at Kroger, traced to a farm that supplied to Walmart, it affects Walmart too. So you want to get the entire ecosystem onto one platform. That immediately tells you, I need to have selective visibility on the data, all the things that blockchain is so good for, right? So information sharing is a key problem in the food ecosystem, and it can be solved. Other problems in the food ecosystem, very quickly, food waste. 1/3 of all food is wasted. It's a mind-boggling statistic across the globe. Much of it is because of information sharing gaps, if you will, that prevent things from being not thrown out, or basically deteriorating products quickly get to the end consumer with, so that it can be used. Freshness. If you buy strawberries at a store, it lasts for typically 14 days from when it's harvested. So when you buy it, you wanted to buy it with as much residual freshness or shelf life as possible. That requires collaboration between the farmer, the trucking company that moves it all the way to getting it to you, to the retailer to get it to you. So all of these problems, and there are many more, by the way, food fraud. You've heard issues of, horse meat being sold as beef and all sorts of other things. In fact, organic food, there's a funny story I keep telling, right? There's more organic food that is sold than is produced. How is that possible? Somebody's paying too much. So all of these things are examples where trusted information sharing a la blockchain can make a huge difference. That was the intuition behind why we started on this journey. And so what we did then was, this is almost 2.5 years ago, we decided we should go with a large retailer like a Walmart and get them engaged to figure out how to get, you need to get all the players who are in the supply chain, right? So if I pick Walmart, I need to get all the people in the romaine lettuce supply chain to do a job with romaine lettuce, right? We got all of them into the mix, and we did a pilot. So the basic idea in IBM Food Trust is use blockchain as a mechanism to do the information sharing in the food ecosystem with respect to tracking food. So what did we do? So the specific experiment we did almost 2+ years ago was, you walk into a Walmart store, you pick up a pack of sliced mangoes, and you said, where did this come from? To answer that question, Walmart, which does it better than most retailers in the world, took about 7 days, right? Normal process. And then we had in parallel done the following. All the players in that supply chain had shared information that was shared into the IBM Food Trust solution, which is built on top of the blockchain platform. And we showed that basically you can get a full trace back in about 2 seconds. No surprises there. All computer scientists should tell you, hey, look, this is a database at the end of the day. It's decentralized and all that. But once the data is sent in, you can obviously trace. Why is there a surprise that it took 2 seconds? In fact, the 2 seconds is partly because there were some Wi-Fi-ish glitches that slowed things down, okay, as you can imagine. But anyway, the way it works, however, is that if you look at it, there are 12 steps that happen in the specific example, right? From the farm, it goes through cleaning process. It came out of Mexico. It goes on a ship to come over to the US, and so on and so forth. Any given player in here, what they were doing is, and very simple to understand, anybody in the picture, say, I'm the company that cuts the mangoes into sliced mangoes, let's say, right? What I receive, what products, what batches of products I receive, what transformations I do on that to create new products and new batches. You create something, it'll be a batch or a lot as part of that problem. Got them together, Driscoll's, Dole, etc. Everybody was asking is, who owns the data? It turns out in our system, the company that uploads the data owns the data. That is a conscious choice we got to by leveraging the feedback from that ecosystem, right? Standards and interoperability. It'll be wonderful if there is only one solution called IBM Food Trust that rules them all. But guess what? There will be others. So upfront, when we started the solution, we had to think through, okay, what are the data standards we will use to send us data? So we adopted something called GS1, for those who are familiar with it, right? And so things like that. And finally, the technology itself. Remember, today IBM Food Trust can support, several billion transactions. I already mentioned Visa does 100 billion transactions ballpark. In the food ecosystem, the number of transactions is going to be orders of magnitude more. So, thinking about how to get to, a future state are some of the concerns also we had to think through. And we have a design, we think, which will scale, but scalability and all the technology elements also have. Our job in pulling together the entire ecosystem, they're all part of the IBM Food Trust. Think of the ecosystem as part of the solution, right? Because that's how the solution gets value. And the key elements we had to add to ensure that you could do this trusted information sharing. And then the specific applications we build on top. More applications will come in future. And then third parties are also building applications, right? So that's how to think about the solution itself. And so some of the things I mentioned earlier, food waste, 1/3 of all food is wasted. We can address it using the data that flows through IBM Food Trust. This is a long journey. It's not like something we do overnight. Over time, we need to get more and more players into the system and add more and more function from us and from third parties into the system. Okay. And this is just to make the point, in the interest of time, I'm going to skip. We had to think through the entire food ecosystem, right? So it's, if you think of strawberries, from the farmers to the packing house, to the trucking companies that move it, to the food logistic companies, it goes to restaurants. So it's not just retailers, restaurants, food services companies, regulators. They also, over time, we expect to be on the system, because if there is a problem, regulators want to know where it came from and want to trace too, right? So all of these things basically will happen over time, but this is our vision of all the players who would be part of this ecosystem. So in a nutshell, the journey has been, we did this mango and pork pilot. We did a pork pilot in China at the same time. In 2017, we formed the foundation program and got their input and got all the things I mentioned in terms of governance and all that. And now IBM Food Trust is commercially available. And in September, Walmart sent a note to all its leafy green suppliers, right, asking them to get on board IBM Food Trust by September of this year. Right? So there is a mandate to get onto IBM Food Trust. Now, unfortunately, in November, when the event happened, not enough suppliers and not enough flow is going on to be valuable. But hopefully, come September this year, things will be different, right? At least for the Walmart supply chain, and maybe others will also join. We've rolled it out commercially globally. So Carrefour is a big champion on the IBM Food Trust today. And Carrefour today, in Carrefour Spain, there is a specific brand of chicken you can go and buy in the store. And when you buy, there's a QR code on it, you scan it, there's a mobile consumer application that hits IBM Food Trust in the back end and surfaces information about the chicken, right? So this stuff is real. Early days, but it is real. These are in production today. I'm super excited about where we have come in terms of the journey itself. Okay. And I wanted to also give you a sense of, so I talked about, when I said blockchain, the database aspect of it, the decentralized database, and I said smart contracts. I want to give you a sense of, and by the way, that's where a lot of the magic in blockchain is, in my view, right, from an application perspective. So this is an example of some work that we have done, a pilot that was deployed, which involved, a beef patty manufacturing company and a restaurant chain basically downstream. And the whole idea was to track the beef patties through the supply chain. But keep in mind, fresh beef lasts only for about 14 days. So if you want to have a hamburger patty, based out of fresh beef patty, you got to get the hamburger patties to the restaurant as quickly as possible. Number two, the temperature has to be within a certain range. So what we did was not just basically be able to trace the product, which we do. In addition, get temperature information into the IBM Food Trust solution. You can share any information, is my point, right? And there were all sorts of cool things like RFID tags and other things in the system. But what we solved is two specific problems. So this restaurant orders hamburger patties. It arrives in multiple batches from the manufacturer. Did that entire order get fulfilled? That's done using automated business logic or smart contracts so that disputes don't happen, right? That's part of what we did. Similarly, disputes around temperature is a classic thing that happens in cold chains. So what we are able to do is have a smart contract that basically keeps track of the temperature and deviations thereof to say that, look, everything was fine, or something went wrong, and yes, it is your fault or it's your fault, right? That's basically what this does. So smart contracts or business logic running on the data and the blockchain is super valuable and will play a huge role going forward. So again, what I was trying to show you all along is if you look at, to summarize, if you look at problems of the food supply chain, most of them, food waste, food fraud, food freshness, food quality, you name it, typically it's an information sharing problem. And that too, information sharing across an entire ecosystem, including competitors. Blockchain is the right answer for that, as long as you can build a solution that has the right governance, the right rules within the rules of the game, if you will, right? And that's basically what IBM Food Trust has done so far. Hopefully, this gives you a good sense that at least, and by the way, much of what I said can be done in every other supply chain too, right? All we're talking about is players in the supply chain send relevant information to solve critical business problems in that supply chain. So we have another solution. If I have time, I'll talk about it a little bit. But I want to get to what I promised you in the beginning. I want to give you a sense of technologically how did we do this, and give you a sense of what are some of the technical challenges. So I'm going to phase 3 of this presentation. Okay. So the first thing basically is to understand is all these players are sending information to IBM Food Trust, which is wonderful. But does the little farmer have a blockchain node? The answer is no, right? The approach we took was there is a selected subset of players in the ecosystem, typically, with a good representation across the globe, who are responsible for managing the integrity of the database. They're called trust anchors. Everybody else, to them, it's like a SaaS, software as a service solution. They send information, and they get various applications that they get out of the system. So what we had to promise that community that may not be running the blockchain is, one, there is a tamper-proof recording, there's non-repudiation using digital signatures, there is verifiability. Anything that you send in, you can provably show that it was sent in and it was not tampered with. There's recoverability. There are these applications with a SaaS set of APIs on top, right? So what if that entire API layer dies, right? Something happens. We can recover the entire system from data on the blockchain, which was a design principle we wanted. And finally, privacy and security. We basically encrypt everything that is stored in the blockchain. And I'll explain why encryption in a second. So these are some of the key design principles we used to create the solution. I want to get to some of the technical challenges. And it starts with, again, simple model. It's a decentralized database. First question is what data gets into the system? The 4 types of data that gets into IBM Food Trust are illustrated there. At a high level, it's what I already told you. Every company says, this is what I got, this is what I did, this is what I sent out, right? That's very simple. But then you also have to send master data about locations, right? It came from some location, from this facility, that sort of thing. This product, strawberries. So product information, that's master data. Transactions, there was a purchase order issued, there was an advance shipment notice, etc. Events, all the things you do. Milk came in, sugar came in, I made ice cream and I shipped it out. Those transformations from ingredients to a product. Those are the kinds of data that come into the system, right? That immediately should make you wonder, what is the technical challenge there? It's about companies have to, from the internal existing systems, find the appropriate data and send it to us. Onboarding of companies onto IBM Food Trust, that is a technical challenge. When we started, it took 6 months, 150K ballpark cost to make it happen. Now we are at 5 to 10K and, depending on for certain companies, and probably 3 to 4 weeks. Big improvement over the last, say, year or so, but there's more to be done. And a lot of this has to do with figuring out the best way to get data from internal systems, or if people don't have internal systems, how do you get it in with mobile apps and things like that? That's onboarding is a key technical challenge that I want to leave you with for solutions like this, and every blockchain solution has this problem. The second is, I'm uploading information. I'm going to say who's going to see the data. There's a big challenge here. Think of a farmer. He's sending something to, say, Driscoll. Strawberries, farmer sending strawberries to Driscoll. He's uploading information about the strawberries. He or she does not know that whether it's going to go to a Walmart or to a Kroger. So you don't know when you send the transaction to the blockchain who the final recipient is. So you cannot share it with parties when you don't know the information when you send it up into the system. So we had to come up with an abstraction that said, or a linked abstraction. You send it and say that you can share it in future with somebody else, provided they're, they're part of that supply chain, right? So we came up with an abstraction, which came with its own problems. So here's the situation, right? The abstraction worked, but remember I said in the beginning, right? The Hyperledger technology has this notion of channels to separate or partition data. Now, you have to dynamically decide the partition here, right? Because the supply chain is the farmer, Driscoll's, and Walmart is one example. Another is the farmer, Driscoll's, and Kroger. These are 2 separate channels. But the assignment of a data element to a channel is not known when the data is sent in. So we came up with an interesting approach to solving this problem, but I think there is a lot that can be done with respect to how do you manage the right levels of access control in a system like this when data is shared. the last word has not been said in that topic, is what I wanted to say. All right, so we solved it with this linked approach, but then this forced us to do the following. The transaction that was sent has to be stored somewhere immediately. So the approach we took is, we said there is this notion of a trust anchor channel, if you will, where all data will be stored in the channel. And then when you want to do a smart contract, let's say between a restaurant and a manufacturer, to use that example of cold chain I said earlier, corresponding data that only they can see is pulled out of this trust anchor channel, unencrypted, stored in a separate private channel where the smart contract is run. So it's done in a two-step process to solve this technical challenge. That's what we did. This is a patented approach we have taken, but there could be other approaches to doing this. But this introduced another technical challenge, which is when all data is stored in one channel, you start wondering, what about the scalability problem? So if everything sits in a one hyperledger channel, how are you going to solve it? We have our ideas about how to solve it, but I think there's plenty of opportunity with respect to thinking about how to solve that problem. So I'll leave that as another technical challenge with respect to scalability. One more thing. Because all data is in one channel, we have to encrypt everything. And to do smart contracts, we have to decrypt and move it over to private channels. But what if homomorphic encryption works super fast today? We can run the calculation or the smart contract on the encrypted trust anchor channel itself. Unfortunately, that's too expensive. So an open challenge is, will cryptographers come up with classes of problems or smart contracts that they can run on the trust anchor channel itself, meaning that one channel where all data gets registered into. So these are other sort of technical challenges that I want to leave you with as ones that could make a huge difference in terms of moving this technology forward. All of the examples, by the way, will apply to all supply chain problems because I gave you generic examples which apply to any supply chain, right? It's not just the food solution that we are doing. All right. How much more time do I have? 7 more minutes. That's awesome. Okay, so that gives me the opportunity to also spend a little bit of time on the last solution. But before I do that, so technical architecture of IBM Food Trust, then I just want to leave you with, since I said so much. At the very bottom, you have the Hyperledger fabric, as always. You have this, the blockchain layer now has some interesting coloring in there. It's got to do with the fact that some nodes are run by the trust anchors, the people who are responsible for managing the integrity. And they run this thing called the trust anchor channel where all data is stored. And then there are others who run private channels where they do smart contracts. That's the way our system works. Remember I said everything goes to one place, and then small subsets of companies get information that's relevant to them in a site, in a private channel where they do the smart contracts. And then all the APIs, the cloud data stores you see above, if all of them get zapped by something, no problem. We have recoverability. We can reconstruct everything from the blockchain, and there are multiple copies sitting around. So that's basically how the system works. And 90% of the work, by the way, had to be done above the blockchain layer. Just to give you a sense of building a solution like this, blockchain is not where all the action is. Yes, it's the reason why we do this, but there's a lot to be done above the blockchain layer to make a solution like this work. Okay. With that, I want to move to another solution, and I think the analogy is so similar that you will get a sense of why I believe supply chains will get transformed. So the next problem we looked at was the ocean shipping industry. If you look at anything you buy today, you go to a store, you buy, I don't know, from tennis shoes to televisions, God knows what. Anything you buy, high likelihood it came on a nice steel box sitting on a big ship. That's a very high likelihood, okay? $16 trillion worth of goods move that way. Now, when these goods move on container ships, there are two significant inefficiencies in that supply chain. One is customs paperwork. Just think about it, right? It can be enormous. In fact, we worked with Maersk, the shipping line, so they are a partner in this journey with us. And we did, this was around 2017 timeframe also, 2 years almost, right? We looked at shipping a container from Mombasa in Kenya to Rotterdam in the Netherlands, avocados. The cost of moving that box of avocados was about $2,000 to $3,000. The amount that the farmer had to pay the freight forwarder, which is a middleman who does all the customs paperwork, $400, 20%. what if we could digitize the entire document workflow, including customs approvals and all that? The right parties approve those. That document workflow could be captured as a smart contract on a blockchain. That's basically the first idea we wanted to embark on. The second idea is location of the container itself. It's crucial information. And I'll tell you why. It may seem counterintuitive. That's like FedEx tracking for a container. What's the big deal? The big deal is, let's say I'm a consumer products company, right? And I get a bill for shipment of containers from a carrier. There are multiple legs. There is a trucking leg in the one end, trucking leg in the other end, the ocean leg. There is freight forwarders. There are 5, 6 invoices that I get to see. I look in there. I have no idea whether I should be paying that amount or not. There'll be a line in the carrier, in the port charge that says, it was stuck in the port for 20 days. There's a storage charge. How do you know it was stuck for 20 days? An information sharing problem. So if all the participants in this ecosystem, it's shown in this nice picture here, from ports to customs to everybody else, get on this platform. It's called TradeLens that we jointly have developed with Maersk, and that was also commercially announced, made available last month. And by the way, both systems are in production for quite some time now. This one is getting about 1 million container events every day, to give you a sense of scale. So these two problems basically we wanted to solve. And what we did is create exactly the same thing, a blockchain-based platform, a solution called TradeLens, where we enable 2 applications. Now, others, third parties, could build more applications on top, right? Like this invoicing application to do invoice-related smart contracts, for example. And that's basically the name of the game. It goes through the same set of things that I talked about. All the things with respect to business value, governance, interoperability, scalability, security, all the things that I talked about, we go through the same thing for the solution too. And this just gives you a sense of the kind of information that flows through the system, to just give you a sense of. But I think in the interest of time, I will wrap up basically here and leave you with just a quick summary of what I covered in this talk so far, right? So I wanted to mention that in blockchain, there are really 2 types. It's a tale of 2 worlds. There is the permissioned blockchains, which are typically the database, the decentralized database is run by a set of known parties. And there is the permissionless world, which has got its own fun and games, ICOs and all the cool stuff, which I didn't touch upon at all. Not too interesting for me. In the permission world, this technology, because it's a database for sharing, can be used in every industry. I've seen examples in all industries, but I particularly like the supply chain space where I'm spending all of my time on. And I gave you that, sort of walked you through 2 examples. Hopefully, I also not only showed you that why it will transform industries, but also showed you it's not as simple as, oh yes, just whip up a couple of lines of code and you're done. I wish it were that simple. It's real hard work, working with companies, trying to figure out, the right governance model for data and things like that. Building the solution. Technical challenges are plenty, ranging from onboarding to scalability to right level of confidentiality. Lots of interesting work is going on in this space, by the way. Zero knowledge proofs is one of them. And things like that, basically, for those who are in cryptography, it's a lot of exciting stuff happening. So this is a wonderful space to be in. Great work happening, a lot of hard work, but a lot of fun too. So hopefully you found this interesting enough that you'll go and look up what is Hyperledger Fabric if you didn't know nothing about it. You would look up what IBM blockchain platform is. You would look up, IBM Food Trust and TradeLens. There's plenty of information on the web also about all of these things. And of course, you can always reach out to me, rameshg@us.ibm.com. I'll be happy to respond to you.
Thank you, Ramesh. Thank you for keeping on time so that we can have a Q&As. But before we have questions, I just want to get a confirmation from you is that IBM is willing to release a academic version for the Hyperledger for all of us to try to play and have the students to play with the blockchain solution. Is that correct?
That's right. So the IBM blockchain platform, there is a starter plan, which is a free plan for experimentation stuff. And we also have an academic outreach leader who I can put you in touch with, who can tell you about all the things that we have on offer to help you guys play around with this technology.
So we will send information out over the HICSS email system so that you can have a link on how to contact IBM. Questions?
Thanks for your wonderful talk. Great work from IBM. I have a question about this work, about the food trust network. Is it really necessary for such an application, food trust network, to apply something like blockchain? Is there any advantage that blockchain got that the other kinds of distributed systems don't?
Yeah.
That's my problem. Thanks.
Great question. So do you need blockchain for IBM Food Trust? Is a very simple question. And the answer is obviously yes, that's why I'm doing it, but I'll explain that. The key is much of the disputes, take the cold chain example, right? There is a temperature dispute. How do you have a single view or a single version of the truth across two parties where both parties know exactly what happened? You need to have some sort of shared way to do it. If both of them agree to have a third party run a database for them, then life is good. But unfortunately, in the food ecosystem, you're talking about all these players, right? Multiple retailers, multiple suppliers, multiple restaurant companies, all of them on the same system. You cannot basically have a single database run by one party. So that's why, so really for trust in these business transactions, to resolve disputes, to prevent reconciliations or avoid reconciliations, you need something like a blockchain technology to make it happen. Or you need somebody you trust, a third party. If everybody says, I'll trust IBM to run this on behalf of everybody else, I could run it on a centralized database, right? So that's the contrast to keep in mind. So every time you have a solution, you got to ask the question, will a centralized database with a trusted third party do the job? The answer is yes, I would not touch blockchain.
Much mahalo for a very nice and impactful presentation on the food supply chains. I'm Benedict from Oregon State. My question is, you mentioned a couple of areas where you need help from the scientific community. One of them was onboarding new companies. Can you give us a little bit more details? We would like to help you, we would like to serve you. If you give us more details about what are some specific problems with onboarding new companies.
Yeah, so I think all the technical challenges I ended the talk with, I think we can talk offline is what I would suggest as the simplest approach. The devil is the detail. There are specific challenges. Some of them are classic ones, like for example, data is coming in. What if the data is noisy? Right? Garbage in, garbage out problem. Blockchains have that problem. Then there is this question of how do you prevent tampering, right? This is a lovely database, all right, trust and all that, but what happens at the edge? If a malicious actor, a customs officer decides to sign off on that document, but he does that based on getting a bribe, that doesn't appear on the blockchain. So we have all these challenges on the edge with respect, not just onboarding, but around things around data coming in that, I just want to give you a flavor. There are plenty of challenges. Happy to talk to you about it offline.
In the United States, medical care is a huge problem. And it costs twice as much as it does anywhere else in the world, something like that. There's very large possibilities of fraud. There are lots of information problems. Doctors hate their information systems, et cetera. So is there any possibility that blockchain plausibly could do anything about that?
So absolutely. So I think I heard healthcare, right? Yes. And so in the healthcare space, there is plenty of problems where blockchain can play a role in. I'm familiar with some of them. Just take drug serialization, right? Or drug provenance. That's a great example where I think blockchain can, it's very similar to what we did in IBM Food Trust. There are other examples too, right? Insurance claims and fraud-related insurance. Can you keep track of information in a fashion that helps you do that better? Clinical trials, right? People halfway through a clinical trial change the goals of the clinical trial. If you had basic goals tracked on a blockchain, those things will be also outed, right? So there are all these examples that I can think of where it would make a huge difference also in that industry. In fact, every industry I expect this to make a difference. But I personally am not involved in projects in the healthcare space, but colleagues of mine are involved and I can introduce them to you.
Gerhard Schwab from the University of Zurich. I have a question regarding the architecture. You showed very clearly that blockchain is good because it's distributed data storage. But then you put everything in the IBM cloud. And if the IBM cloud goes down, everything goes down. So what's the sense of having a centralized cloud in a for decentralized data storage?
Yeah, so this is a fantastic question, and I think, you know, the answer, as you can expect, is absolutely agree with you. So it's part of a roadmap, right? When you start with a decentralized database and you have multiple parties running nodes, in the early days, you have the weakest link problem. The weakest link who runs the node badly, poorly, perhaps, is going to be the security problem. So we decided upfront, in the initial days, we will run it all in the IBM cloud. But as we already announced for IBM Blockchain Platform about a couple of months ago, we are relaxing it at the right time. So what we can do now is the nodes in the blockchain can run on multiple clouds, right? So we allow that. You can run on-premise to some of the nodes. So these are all basic. Think of it as there is a journey that we are in from a technology layer point of view. At the right times, we want to get to an eventual end state is people who are running the trust anchors who are running the nodes can run it anywhere is where we want to go. And that's the path we are on. So this is, think of it as a point-in-time statement because we wanted to start somewhere we can, I want to make sure that IBM Food Trust is a solution that works and is trusted. So I wanted to make sure that things work correctly first. As the blockchain layer underneath does all these things I said in terms of running everywhere, we will inherit that in the solution. Hope that answers the question.
I'm Tommy Dabak from Turku School of Economics. So we are running a project where we have both WeTrade and Marco Polo, which is runs on Corda. And we would need to, in a way, integrate two blockchains. So how far do you think we are in integrating various blockchains on different platforms?
Yeah, this is a fantastic question. So this comes to me all the time. This is really the interoperability question, right? So the gentleman just mentioned that there are a couple of trade finance solutions, Marco Polo, WeTrade, I gave an example of, out there. Just like, right now there's no alternative to IBM Food Trust, but somebody's going to come up with something soon, right? The thing is, what do you do about interoperability? And I'll give you my answer about how to think about interoperability in the next 2 to 3 years. Longer term, there are other options. Interoperability between solutions, you got to think in terms of 3 things. The first is, you need to know the identity of companies in 2 separate solutions. So for example, if Walmart is in this solution, Walmart is in that, or if Walmart is in Marco Polo and Walmart in WeTrade, both should resolve to the same company, Walmart. So identity resolution is important. The second is data standards. Why? Basically, you know, if, after all, at the end of the day, it's a database on both sides. There's some data here that has to be moved over to the other side. If they both use the same data standard for inbound data and outbound data, life is good. So that's why we embrace GS1, which is an open standard. For TradeLens, we embrace a standard which we are trying to, we had to come up with something which we are contributing to a standard. Let me put it that way, right? So data standards is the second piece. Identity, data standards. And finally, governance. This is the most important thing. And this is the reason why I prefer this 3-part approach to interoperability. The reason why governance is important is because think of IBM Food Trust on the one side, and let's call it some other company Food Trust, okay? The governance model in these two are very different. Let's say, you know, IBM Food Trust is very careful with the data. We'll only share it with companies you share it with. Here, we are more relaxed. So when data is moved from this system to that, you'll be breaking the governance in this system, in IBM Food Trust. Not okay. So you need to have discussions around the governance also before you do it. This is the reason why a lot of people talk about interoperability of blockchains at the level of the raw blockchain technology itself. They talk about Hyperledger Quilt and all sorts of projects. They're all fun and games, but the reality is when you really want to build solutions that run in the real world, you have to face all these problems. So it's better to start top down and over time solve it at the lowest level. So start at the solution level to solve the interoperability initially, and over time get to the technology layer. That's my, you know, that's the recommended path. At least that's the path that's our strategy, and that's the path we're on.
Thank you. I know there will be more questions, but we are running out of time, and I would welcome you to come and talk to Ramesh offline, because I don't want other speakers to be waiting for you guys to come back to the sessions. So with no further ado, thank you so much, Ramesh, for the talk. And also thank you, IBM, for supporting this talk as well. Thank you, and have a good afternoon.